actually, far from being dangerous and sort of horrible events, we very much may owe our existence to them. Because when galaxies collide, all of the gas and dust contained in them gets swirled up. And in fact, even the spiral arms of our galaxies, we believe were probably caused by collisions long ago with smaller galaxies. And there are two tiny little galaxies the Milky Way is absorbing right now. They're actually in the disk of the Milky Way, the Sagittarius dwarf and the Canis Majoris dwarf galaxy. And the only reason we ever discovered them, this was mainly with surveys with Spitzer and 2MASS, some of our infrared astronomy surveys, is that you see these streams of stars all going in the same direction, kind of like in big rivers. And when you do the computer simulation, you see it was a little body that got smeared out by the Milky Way's gravity. And one of the fun little trivia things is we're actually closer to the center of the Sagittarius dwarf galaxy than we are to the center of the Milky Way. And when you look at some of the stars in the night sky, those are stars from other galaxies that the Milky Way has absorbed. Next slide. So here's another beautiful Hubble picture of one of these colliding galaxies. In this case, two galaxies have collided and left sort of a stream of stars coming off just from the tidal forces of that collision. And this is one of these Hubble pictures that just, I mean, I've seen it hundreds of times, and it just blows my mind every time because all of these little dots are galaxies, right? You know, if you see something with the diffraction spikes on it, that's a star. Those spikes are just caused by the starlight bouncing off the inside of the telescope, basically. But everywhere you don't see that, that's actually an entire galaxy. And,
so whenever you're saying that they're colliding, I mean, I know that I've heard, I don't know what the general consensus, you know, what's at the center.
Right.
You know, the question of a black hole or this, that, or whatever.
Absolutely.
I mean, do we know what happens when they collide? Are those whatever's in the middle merge?
Yeah. Oh, yeah.
Okay.
So that's one of the big things right now. I mean, not so much for the. I think the James Webb will certainly help to some degree, but that's one of the things we're hoping to see with our gravity wave detectors, because we believe what happens is that the black holes will merge into a single big black hole. As they do so, they're going to set off gravitational fireworks, you know, bending in space and time. And so we would hope to see these gravity waves that get sort of bigger and faster and faster and faster, than blam, you know, and then nothing, as these things actually come together and spiral in. So if we ever get really good at observing gravity waves, we hope to have actual evidence of merging black holes. Yeah, definitely. Now, we were talking about the size of the sun compared to the Milky Way, and that gives you some idea why we say that the chances of two stars physically colliding are almost nothing. And it will be pretty spectacular for the sun when we're colliding with Andromeda. There'll be this big galaxy coming at us in the night sky. But the chances of anything bad happening to us are pretty much nothing. Now, one of the fun things, I mean, the sun could easily be streamed off the galaxy when that happens. Or we could even be thrown in closer to the center of the galaxy. But this goes very, very slowly. It takes, you know, millions or billions of years for the collision to happen. And as the sun, I mean, let's say it got thrown off. I mean, as the sun would move away from the galaxy, the Earth would happily just keep orbiting, you know, exactly the same way around the sun. So it might be a lot of fun. But well, if you could, millions of years to watch it.
How can we say that for sure that, I mean, we won't be impacted or not? Whatever's here at the time, would it be impacted with some planet or asteroid comets?
You know, there's always a chance, right? I mean, so we have been around the Milky Way in and out of the spiral arms 20 times in the lifetime of the sun. And, you know, some people have said, you know, we go through denser and less dense regions of the galaxy as we go. Could that be related to extinctions? You know, could it be related to things raining down on us? We can't tease out a very clear pattern. It's not quite as simple as that. But, you know, it's one of these things, you know, do you really expect to win the lottery? There's a chance two stars could physically collide, but when you do the mathematics.
Depends how realistic you are in terms of expecting to win the lottery.
It's really, really, really unlikely. I mean, it could happen. It's not absolutely
impossible. I just imagine, I mean, especially at the angles that are simulated with the billions of stars in each and then the billions of planets.
Yeah, but you gotta get the density of these things. I mean, it's like, you know, in this room, if there were two air molecules, only two air molecules, what's the chance of them actually physically colliding?
Right.
You know, they're really, really sparse things when you actually take them into account.
We're really quarantined.
Sorry?
We're really quarantined.
In some ways, yeah.
Really
Yeah.
far.
That's right, really far from things. Anyway, next slide. So here's a little gallery of colliding galaxies, and like I said, the Hubble Space Telescope sees a lot of these, and Webb will see even more. And the thing to really pay attention to, that we've noticed for a while, is that when galaxies collide, you get this burst of star formation. You get a new generation of stars that kick off. And you can see that because wherever you see blue stars, stars that burn so hot they're blue don't live very long. They actually only live a couple million years. They burn through their nuclear fuel much faster than the sun does. They burn much hotter. And so wherever you see blue stars, you know star formation is happening right now, or very, very recently. And when galaxies collide, we see them light up. Something gives all of the dust and gas a chance to mix together and bits to start to collapse under gravity. So, I mean, it really is true. I mean, what set off the formation of the sun? Some cloud of dust and gas decided to collapse. Why? It may have been one of these nearby galaxies slamming into us that did that. So, you know, we may be very, very related to this creation cycle of galaxies merging together. When you look farther out into the universe, galaxies are smaller and more irregular. And that means long ago, there were just greater numbers of little galaxies, and they're now merging into bigger and bigger galaxies over time. Next slide. So what's happening inside that galaxy? There's a beautiful Hubble image of a single galaxy, beautiful spiral, very much like the Milky Way, and you can see all of the gorgeous dust clouds and the spiral arms. All of the dark material is dust that's absorbing the starlight beyond it. And a lot of people don't seem to realize that the arms of galaxies are not solid things. And when a galaxy rotates, the arms don't stay in the same place. The stars move in and out of spiral arms, very much like cars moving in and out of traffic jams. So, you know, the sun, like I said, orbits the center of the galaxy about once every 240 million years. So we've been around about 20 times. We've been in and out of spiral arms as we went around. The spiral arms do have a velocity of their own, but the stars are actually faster. They go in and out of them. So the spiral arms are density waves that we think are probably set up by gravitational encounters with other galaxies. And then as stuff moves into these denser areas, it gets smacked by density waves and starts collapsing and forming new stars. And so you see you have this wonderful dark lane of dust, and there are red regions actually in the dust, which indicate where stars are forming. The red color is from very hot hydrogen that's become ionized in a new star-forming region. And then right outside of that, you have all these blue stars. You see that there's a wonderful collection of blue stars right outside the spiral arm. These blue stars will not survive long enough to make a trip around the galaxy. So you'll only see these blue stars crowded up right by the spiral arms, and then they will die quickly before they can actually move around. So, you know, this is sort of how a galaxy works, how you get something like a star. Next slide. This is actually just kind of a beautiful image. This is from the Spitzer Space Telescope. I was a postdoc at Caltech when I started working on the Spitzer Telescope, and then that's my first job at NASA was at the Jet Propulsion Laboratory. And this is actually looking into the center of our galaxy. We are in, of course, a dust ring. I mean, we're in a disk of dust and gas. And invisible light, that obscures the sky. We actually cannot see more than a couple hundred light years away, for the most part, if you look in the disk of our galaxy. Everything like the Andromeda galaxy, we're looking up out of the disk where the dust isn't quite so dense. But if you look in toward the middle of the galaxy along the disk, you do not see very far. And in infrared, as James Webb will be, you can see right through the dust. The dust has to be pretty dense to actually not be able to see through. And as you can see, there's some areas of dust that still show up in the infrared. But this is an infrared image from Spitzer. The center of the galaxy, about 30,000 light years away, is somewhere in here. And this is one of the first times we were able to look clear across the disk of our galaxy. You know, there are nebulae and star-forming clouds in here that we've never seen before. And this image is just gigantic. I once went to Griffith Observatory, and I enrolled an 80-foot-long version of this image. And we let people, you know, sort of point at things and say, what's that? So I often get questions from school kids as to why I can't show them a picture of the Milky Way galaxy. And of course, you know, it's like, well, we have not sent a camera, you know, millions of light years away in order to see that. Or, you know, you take quite a distance to see that. But here we are in the middle of it. And it's just a gorgeous thing. Next slide.
But based on how dense a circuit